In this short video, I'd like to show you how to solve an empirical and molecular formula type problem when you're given the mass percent composition. Now, this is the exact same question that's in your homework. I wanted to design a question where you could not just take the question stem and put it into Google or ChatGPT and have it spit out the answer. I wanted you to see the work. I wanted you to see the steps. The disadvantage of this kind of problem is there are many spots to input answers and things can go wrong. You may not be aware of exactly how I want you to input the sig figs or the exact approach. So I want to show you exactly how to do this problem, and then you'll see a similar sort of problem in the quiz. Now, when you do the quiz, you'll get a final result, and should it just be a very small error or an error that you don't understand, you can always email me, and I can give part credit or full credit. But for the homework, of course, you can't go on until you get it perfect. So let us proceed. You may recall that in any empirical formula type problem, the first step is to find the mass of each of the elements. In this case, we're going to assume exactly 100 grams of compound, and therefore each of the given percentages will equal the exact mass. One of the things that you can do is rather than type in these masses, you can actually just copy right from the screen and input in this fashion. So that's what I'm going to do. I'll fill in the rest of these values because I've shown you how to do this. Okay, now we have all the masses. The next step is to calculate the amount of each element in the compound, because of course an empirical formula is not a mass ratio, but rather a mole ratio. Now, to reduce the amount of work, I've already calculated the amount of hydrogen and the amount of oxygen. Of course, I just took these masses and essentially divided by the molar mass. So now, if I find the amount of carbon, I will find that the answer here equals, and note, I've got to pay attention to significant figures. If you don't, you will get an incorrect answer. So this would be 4.119.3. And so I've got 5 sig figs, I've got 5 sig figs. In this case, I don't want you to include extra sig figs and assume that they're subscripted or whatever. You need to round to the correct number of significant figures. Now let's take a look at the nitrogen. So this, if I divide by the molar mass, will give me 2.0603. Okay, so I need to be very careful in inputting those numbers. If they're off in terms of the sig figs or how you've rounded, it'll be incorrect. Now I need to find the mole ratio. And perhaps you already appreciate that the smallest amount here is the oxygen. So of course, when I divided each of these numbers by the amount of oxygen, well, I get, of course, exactly 1 for the oxygen. And so far, I'm going to maintain the correct number of sig figs in case I need to pay attention to the fact that it's not exactly close to an integer. So you might imagine that if I divide this 4.1193 by the amount for oxygen, it's going to be a number pretty close to 4. And again, to 5 significant figures, it comes to the following. So this is 005. And then I've already done this for the hydrogen. Now for the nitrogen, this comes to 2.0009. So now I have the mole ratios. From there, you can see that these mole ratios are very close to integers, and I should be able to come up with the empirical formula. So I hope it's clear to you. This will be 4. This will be, well, not -1, but rather 5. This, of course, will be 2, and this one will be 1. So note, the exact empirical formula will be perfect integers. The last step is to come up with the molecular formula. In order to come up with the molecular formula, I need to see how much bigger the nominal molar mass is compared to the empirical formula mass. So the nominal molar mass is given as 194. The empirical formula mass, so what we do is we calculate what is the molar mass of 4 moles of carbon plus 5 moles of hydrogen plus 2 moles of nitrogen and 1 mole of oxygen. When you do this, you actually come up with the number 97. So it should be pretty clear that the ratio between these two masses is 2. Therefore, the molecular formula here will involve an 8, so I double that 4, will involve a 10 for the amount of hydrogen, will involve a 4 for the nitrogen, and a 2 for the oxygen. With some luck, when I submit, I have the correct answer, and so hopefully this works for you also when you do this homework. Again, I designed this to simulate how the calculation would go if you were doing this on paper. I hope you find it of benefit. And as a last note, this chemical is consumed by billions of humans every day. Can you think what this chemical might be?